Okay, here is the lesson about quadratic applications. This is where we talk about quadratics in real life. We're going to take these key features that we have talked about on day one, the y-intercept, the x-intercept, the y part of the vertex, and the x part of the vertex, and match them with the words that you would find in a story problem. So on the right, when or where the object hits the ground is the x-intercept. So those two match. When or where the object is at its max height, well, that happens at the turning point, if you remember, and we call that the vertex. So when or where the object is at its max height is the x. This is the when. The x is telling us the when. Usually x is time. The initial height of the object is the y-intercept. That's when usually time is equal to 0. Usually this is time equals 0. And then the maximum height of the object is the y part of the vertex. And here we're looking for maximum height. So what we're going to do today is look at some examples and use the story problems to answer these questions. So in the first one, it gives us a graph. And it talks about a rocket carrying fireworks is launched from a hill above a lake. So we've got a lake down here, and we have a hill right here, and we have our rocket. We've got like a rocket. Okay, so he's launched at that hill. So the rocket's going to fall in the lake after exploding. So sometime over here, it's going to explode and then fall in the lake. The rocket's height above the surface is where y is the height. Okay, so I'm going to go ahead and label this axis height. And x represents time. And we're going to just say in seconds so that we have a measure of time. So the first question says, at what height does the rocket start? Well, we're going to look right here. Oh, I covered it up. So let's see. At what height does that rocket start? Well, if we look right there, the y-intercept is 80. And it has told us that, oh, it doesn't tell what it is. We're going to say in feet. Sure. So it's 80 feet. How high is the rocket after 1 second? Well, time in seconds is x. So I go to 1 second, which is right here. And I'm just going to draw up, right there, 1 second. So at 1 second, we're going to say it's at 130 feet. Then it wants to know at what height will the rocket explode? Well, that's at its max height. It's right here. We don't have an exact, but we can call it something like 145 feet. Then how long will it take for the rocket to hit the ground? Okay, so this question is asking us how long. So it wants to know how many seconds. Here's where it hits the ground, and that's after 5 seconds. Okay, so that's how we do one when we have the graph with us. This one doesn't have a graph, so it's given this equation, -3 parentheses x minus 4 squared plus 147. So what I want you to do is on your Chromebooks, I want you to go ahead and pull up Desmos. So we go to desmos.com. Instead of going to a code this time, we're just going to go to the graphing calculator, and we're going to type that equation. So we're going to do y equals, you're going to have to let me go back and forth for a minute, -3 parentheses x minus 4, close our parentheses, squared, was it minus 147, plus 147, all right, plus 147. So you can see here that mine is too big. Well, my graph is too big, so I'm just going to zoom, and there I have it all on my graph. So those of you with graphing calculators can do this too, but it's a little easier on Desmos because the window will always be easier to zoom in and out of. So let's go see what the questions are asking me. What is the maximum height that the arrow reaches? Well, maximum height, if I come back to my thing, my initial where it tells me what maximum height means, maximum height matches with the y part of the vertex. Well, hey, this one is in vertex form, and my vertex my vertex happens to be at 447. We learned how to find that on the first day. So the maximum height, because this is the x part of the vertex and that's the y part of the vertex. So my maximum height is 147 feet. The second question says, after how many seconds does it reach that height? Well, I've already got the x part of my vertex, which x part of my vertex, when or where the object is at its max height. All right, I've already got that. It's 4 seconds. How high will the arrow be after 6 seconds? Well, that one I can't find from my formula. I could do, if I didn't have the graph to look at, I could do this way. I could do the -3, and where x is, because that's our seconds, I could do this and plug it into a calculator. So that's one option. The other option is to go to our graph on Desmos, and we're going to zoom in and find 6 seconds. So 6 seconds is right after the 5, and I'm just going to scroll up. Yes, I could zoom out. 6 seconds. Well, if you see, I can click right on here and move this dot. And I want to know when the x is 6 seconds. Really close there. Let's see if we can get it real close. Oh, hey, right at 6. I don't know if you can see that. It flips on 135. So you can get that either by plugging it in or by looking on the graph. So we have 135 feet. At what time does the arrow land on the ground? Well, if we come up here, arrow land on the ground, that is when or where does the object hit the ground? Okay, and that goes with our x-intercept. So if you remember from the first day, this is when y is equal to 0. So one thing I could do is I could put a 0 here where y is, and then I could write this out, and then I could solve it for x like we did in our last unit. But the other thing I can do is come to my Desmos. I can come down to the x-intercept. Hey, and if I click right there, it will let me click and it tells me it takes 11 seconds. That was a lot easier than solving it. So we're just going to say 11 seconds. All right, so then on example, oh, I love that I didn't remember to, let's call this example 3, which it is. All right, so we have a new equation. A softball is being thrown this time. The equation that models the curve is expressed by this. Use this equation to answer the following questions. All right, well, what is the starting height of the softball? So I need to come back up here and let's find starting height, initial height. Initial height of the object matches with the y-intercept. All right, well, this one is in standard form. And if you remember in standard form, my y-intercept is c. So the starting height of the softball is at 58.8. Does it tell us the equation models the curve? Well, it doesn't tell us if it's in feet. We're going to just say it's in feet this time. Okay, so what is the starting height of the softball? It is 58.8 feet. What is the max height? I don't know the vertex. I don't know the other things. So what we're going to do is go ahead and go to our Desmos calculator. Instead of the h, I'm just going to type y equals again. You can type the h. It will still work fine, but we're just going to use y equals. Y equals -4.9. -4.9. And instead of, oops, nope, I don't want to square that. I'm going to use x squared. I'm going to use just the x instead of the t. It's the same thing. It's just a variable. Plus 19.6t. 19.6. I'm going to use the x instead of the t. Plus 58.8. Plus 58.8. And there is our parabola. Again, you can zoom in and zoom out, get it to go wherever you'd like on the graph. Let's go back and look at our questions. Number 2, what is the max height the ball reaches? All right, max height. We're going to go back here. Max height is what? Maximum height. Oh, it's right here. Maximum height of the object is the y part of the vertex. So we can come up to our vertex and I can click on it and it tells me the maximum height is 78.4 feet. So 70, our first question is 78.4 feet. How long does it take to reach the max height? Remember that you need to read to make sure you answer all the questions. So I come back here. It takes 2 seconds to get there. It takes 2 seconds. We want to make sure that there's 2 question marks. I have 2 answers. At what time will the ball hit the ground? Well, if I come to my graph and I think, okay, she threw the ball and then it hits the ground, here's where it's going to hit the ground. It hits the ground at 6 seconds. 6 seconds. All right, how high is the ball after 2 seconds and after 5 seconds? So we have 2 options. I can plug in everywhere there's an X. I can do my parentheses and I can just plug that into my calculator. Or I can look, and we're going to do 2 seconds, and we're going to do 5 seconds because there's 2 question marks again, so we're going to do 2 answers. 2 seconds and 5 seconds. All right, let's come here. 2 seconds. Get to the top of this thing. All right, 2 seconds. So after 2 seconds, after 2 seconds, hey, that's the maximum. We already had that one. I bet you guys already figured that out. 78.4. 78.4. Okay, how about after 5 seconds? Well, this time I'm going to do this. Click on it. Let's see. 3. 4. I'm getting close. 4. Oh, wait, not quite there. And, oh, look, so close, so close. 5 seconds is 34. 34.3. 34.3. And we're going to call it feet and feet because that's what we've done before. Don't forget that you need to label your things. All right, once you have finished filling out these notes, you can go ahead and grab your homework. Thanks, guys.